Today we're going to look at dividing with rational numbers, specifically dividing with fractions. You probably know a rule for doing this, but today we're going to look at some different approaches to dividing by a fraction and then talk about why the rule that you already know works. So again, yes, I know you already know a rule for this, but don't be academically arrogant. The question becomes, well, why does it work? And because Mr. Shives told me that that's the way it worked isn't really a good enough answer. So let's take a look at this. Madison and Ramona were working the following problem, but each in a very different way. So Madison took this 3/5 divided by 1/3. She divided the square up into 5 equal pieces, shaded in 3 of them. So the part that's shaded is 3/5. Then she divided the square into 3 pieces horizontally. Why 3 pieces? Wait a minute, because I can't tell where people are when they just start talking, I need hands. Yes, ma'am. Because 3/5 is what? Well, that's true, but that doesn't explain why. I could have divided it into 12 pieces horizontally. Why did she choose 3? Okay, so it may not be immediately obvious why she chose 3. Here's why. She's dividing by 1/3. Do you see how each one of these rows going across is 1/3 of the whole thing? Oh, sorry. I apologize. Wait for a second while that comes up. 3, 2, 1, go. All right. So each one of these rows is 1/3 of a square. When you say you're dividing by 1/3, it's the same thing as how many groups of 1/3 do I have? Let's back up for just a second. If I have 6 divided by 2, what that really means is if I have 6 of something, how many groups of 2 can I make? I can make 3 groups of 2. What we're doing here is asking how many groups of size 1/3 can I make out of this 3/5? And that's why she divided this equally this way. Okay, now she still has 3/5 because 9/15 is 3/5. So that's why it's legal. She hasn't changed how much she has shaded. And then what she did was she rearranged this. She moved, let's say that she moved these 2 up here. She moved 2 of them up to the top row and 1 of them to here. So how many complete 1/3 does she have? Remember, each of these is 1/3. How many complete 1/3 does she have shaded in? She's got 1 complete 1/3. And how much of this next one? Well, there are 5 parts, and she's got 4 of them. She has 1 4/5 1/3. Okay? That's why this works this way. Now, Ramona did it a completely different way. So while we're on page 1, I'd appreciate it if everyone was on page 1. If I'm boring you, I'm sorry. So what she did is she said, okay, division is a fraction. If I have a fraction, that means divide. So I've got 3/5 divided by 1/3. And then she's like, I don't want to have a fraction on bottom. So she multiplied by the reciprocal of that, which is 3/1. The nice thing about that is that up here on top you get 9/5. On bottom you get 3/3, which is 1. And any number divided by 1 is itself. So what she multiplied by is the reciprocal of the denominator, which you can then simplify. So let's take a look at these. We want 4/5 divided by 1/2. So I'm going to start with a square. I don't want that one. I want something bigger. Why is this being that way? Interesting. All right, and then I want to divide it up into 5 equal pieces and shade in 4 of them. I don't think, what the heck? I'm sorry, I don't know what's going on there. Weird. I'm sorry? Connect the lines. I'm just going to draw it freehand. I don't like the way this is working. So I'm going to start off with the square. Does it matter which way I divide it into 5 equal pieces? No. So I'm going to try to divide it into about 5 equal pieces this way. And then I'm going to shade in 4 of them. Pardon? Do you do this? Yes. Yeah. And then I want to divide that into groups of 1/2. So I'm going to go across this way. You always go the opposite way for the other one. And since it was 1/2, I'm going to divide it into 2. So this whole row is 1/2 and this whole row is 1/2. To make a full row, I'm going to move this one up. So that would be 1 full row of 1/2 and 1, 2, 3. Remember, this one got moved up out of 5. It's 1 3/5. So let's do it the other way. So if we have 4/5 divided by 1/2, our supergiant 1, as they like to call it, is always going to be the reciprocal of whatever's in the denominator, so I can get rid of it. So we multiply by 2/1 over 2/1. That gives me 8/5 divided by 2/2, which is 8/5 over 1, or 8/5, which is 1 3/5. All right, so let's take a look at this next one. We want 1/2 divided by 2/3. All right, so I'm going to start with the square. I'm going to divide it in half. And I only have one of those halves. Now, this is talking about thirds, so I need to still divide this into 3 pieces the other direction. So 1, 2, 3. So I'm going to move this one up here. Now, 2/3 is this whole first two rows, isn't it? Each one row is 1/3, so this would be 2/3. Do I have a full 2/3? Is every box in that 2/3 colored in? Be nice to get a little more out of you. I got a couple of, shy shakes of the head. Do I have everything up here shaded? Yes or no? No. How many parts do I have shaded? Well, I've got 1, 2, 3 out of 4. Should be 3/4. Let's do it the other way. So it's 1/2 divided by 2/3. It's the worst 3 ever. For my supergiant one, I'm going to use the reciprocal of what's in the denominator. So I'm going to multiply top and bottom by 3/2 over 3/2. When we do that, we get 3/4 over 6/6. And as always happens at that point, we've got 3/4 over 1, which is 3/4. So that's, again, why this works. Now, in terms of actually doing this, mathematicians are incredibly efficient people. Some people say they're incredibly lazy. Take your pick. They're like, we could go through all of that, but every single time what we ended up with is the first number times the reciprocal of the second number. So let's do that on these problems. This is going to be -5/8 times the reciprocal of 1/3 is what? 3 over 1. So it's -15 over 8. Or if you prefer, 8 goes into 15 once with 7 left. So it's -1 7/8. For this next one, I know that if I'm going to multiply fractions together, it's nicer if they're both fractions, not a mixed number. So how do I change this into what's sometimes called an improper fraction? Yes, sir?
You multiply the whole number by the denominator and then add that to the numerator.
Exactly right. Well said also. You take the whole number times the denominator, because 1 is 4/4, and then add 3 to that. So this is going to be -7/4 times -5 over 2. Remember that a negative number times a negative number gives you a positive number. So it's 35 over 8. 8 goes into 35 4 times with 3 left over. So it's 4 3/8. Okay. Let's take a look at this one. So, Gerard loves to cook. His aunt visited Switzerland and brought him back 4 pounds of Swiss chocolate, which is really good stuff. Gerard's favorite cookie recipe takes 3/4 of a pound of chocolate. How many batches of chocolate cookie recipe can Gerard make using all the chocolate that he has? Okay, so we're going to take all the chocolate that he has, 4 pounds, and it'd be nice if I made that into a fraction. What is 4 as a fraction? 4/1, thank you. And I'm going to divide that up into 3/4 of a pound for each one. So that's 4/1 times 4/3. We're multiplying by the reciprocal. That's 16/3. So he can make 5 1/3 batches. Anytime you're doing a problem that has some kind of units in it, you should have units in your answer. 5 1/3 what's? 5 1/3 batches. All right, let's take a look at this last one. Lauren's bringing food to a party. She bought a 4-foot sub and cut it into servings that each were 3/5 of a foot long. By the way, this is one of those ones where I'm like, really? 3/5 of a foot? I don't even know how much that is. Because a foot is out of 12 inches, having 3/5 is really, really difficult. Anyway, how many servings did she get if she used the whole 4-foot sandwich? So we've got this 4-foot sandwich, 4/1, divided up into pieces that are each 3/5 of a foot long. So that's 4/1 times 5/3 is 20/3. Dividing 3 goes into 26 times with 2 left over. So she had 6 2/3 servings. Again, be sure that you have the unit to go with that. Okay, any questions? Okay.